Hi, this is Dr. David Branham. Today we are doing a video on Chapter 2 of your text, Thinking Like a Researcher. This video will be a supplement to the reading. It's not meant to replace the reading, but I do plan to be very comprehensive in this video, covering just about everything you need to know for your test. So hopefully this video will be helpful. And we'll start by sharing the screen. Let me share. Go. My PowerPoint here. Chapter 2 is Thinking Like a Researcher, as I said. This chapter is rather short. There's only going to be a few questions in your test, and it is not a lot of pages, but I would highly suggest that you learn a lot of everything that is on those pages, because in this course, I don't usually like to assign reading that you don't really need. And that means that it's going to be short, but you need to know everything in it. So let's get started. Page down. Oh, there it is. Sorry. Okay. This chapter starts out with concepts and definitions that are important for research. It'll be important for you to know these going forward. So these are the terms that we're going to cover in this chapter. One is unit of analysis, probably the most important term in research. Constructs, hypotheses, operationalization, theories, models, induction, and deduction. So we're going to go over these in this chapter. First, units of analysis, or the unit of analysis. The unit of analysis in research refers to the collective or the object that is the target of your investigation. In a lot of cases, this is the individuals. If you do survey research where you survey individuals and then you try to find out the variability between individuals, your unit of analysis is the individual. It can also be other things like a country or a school. I did an analysis myself that looked at the infrastructure of the schools to see what effect it had on the attendance in those schools, and the unit of analysis in that particular research was the school, not any individual within the school. Sometimes we analyze countries. In comparative politics, a lot of times the unit of analysis is a country, where we compare one country to another to see what they're doing policy-wise, what demographic variables in those countries have an effect on certain political or social issues. It could be a firm, like you can study corporations. You can even study web pages. We do that in nonprofit analysis. I'm teaching a class on social media in nonprofits, and we are looking at the Facebook pages of CEOs, and our unit of analysis is the Facebook page. So understanding the unit of analysis is important because it shapes what type of data you will collect for the study. I mean, if you don't understand that before you get started, then you can't get started. You need to know what you're going to collect and who you're going to collect it from. And the unit of analysis will be the line in your analysis. If you're doing a spreadsheet, the unit of analysis will be, if it's an individual, it'll be each individual. If it's a school, it'll be each school. That's on your spreadsheet. And then you will collect the variables on each of those units of analysis. Constructs and variables. In social sciences, sometimes we don't use the word construct a lot. This book does. We use variables as a term all the time. A construct is an abstract concept that is specifically chosen or created to explain a phenomenon. That's the definition in the book. But it could be, just a simple concept like a person's weight. Or it could be something more complex, like a person's intelligence. How do you measure somebody's intelligence? Well, typically we get a battery of tests or test questions to see if you can answer those test questions, and then we give you a score on that. But there's all kinds of concepts that you can test as well. For instance, one example they use is vocabulary. In vocabulary, the construct is communication, and vocabulary is used to measure that construct. So a construct can be simple, like a person's weight. These are called unidimensional constructs because they only have a single indicator. A person's weight only needs one indicator. It could be pounds, it could be grams, it could be ounces, but you can measure it on that one indicator. A construct may be a combination of a set of related concepts, such as a person's communication skill, which I talked about a second ago, which can consist of something like a person's voice. My nephew is a radio broadcaster, and people say he has the best pipes in the business. So his voice is very important. Vocabulary, syntax, your ability to spell, your ability to write. These are all parts of your communication ability. So if you were going to give a person a communication score, you might take all of these together, a multi-dimensional construct with multiple indicators to determine what communication skill is. Sorry. Okay. Constructs and variables continued. So constructs, as we saw on the last page, are something that we can measure, but the variable is a measurable representation of that construct. Okay. For instance, pounds can be used to measure weight. Historically, IQ has been used as a measure of intelligence. Survey research often uses a battery of questions. For instance, if you wanted to measure a person's empathy, you can have a battery of questions that tries to determine how much that person cares about other people and the decisions they make. Dogmatism, how intolerant somebody is of other opinions. Those can be measured in multidimensional ways in survey research. So variables are that measure. A variable may be, just one survey question that measures that construct, or it could be a multiple set of survey questions. A variable will change by the unit of analysis. The unit of analysis is never steady when it comes to constructs. If you have a construct for your unit of analysis, say it's an individual, and the construct is communication skills, the communication skills of individuals will vary across your analysis. So that's where the variable comes in. And we typically call constructs variables. That's typical in social science, but that's not what the terminology uses in the textbook. So I just want to make sure that was clear. Variable classifications. Now, it's very important going forward in social sciences and then statistics to understand the variable classifications. A dependent variable and independent variable are something that you need to go ahead and get into your head right now, what those are, because people get these mixed up all the time. The dependent variable is the variable that is impacted by other variables or is explained by other variables. An independent variable is the variable that has the impact on the dependent variable. So a dependent variable, there are a lot of dependent variables, and basically what you're looking for in a dependent variable is something that will be impacted by an independent variable. For instance, your weight. Your weight could be a dependent variable. An independent variable would be how much you eat. That's a very simple one. There's a lot of independent variables that affect things, though. For instance, how much you eat is not the only thing that affects how much you weigh. So weight could be a dependent variable, and it can have several independent variables. For instance, how much exercise you do, perhaps a metabolism index that you have. All of these variables will have an impact on how much you weigh. It could be where you live. If you spend a lot of time in cold weather, very cold weather, you eat a lot of calories if you're in very cold weather. So that may also have an impact on your weight. So these variables, you may have a whole lot of independent variables that have an impact on one dependent variable. In most cases with hypotheses, we're looking at one or two independent variables. So we're looking to see if those make a difference in the dependent variable. But as you're going to see in the other chapters, it's going to be important that you control for those other independent variables. Otherwise, people will say, For instance, it's those independent variables are what's causing the real impact. So you're going to have to control for those variables in your hypothesis test. A dependent variable can be affected by several independent variables. Control variables are used to specify models. Those are those other variables that may have an impact, control variables. They're used to specify models. And when I say specification, I'm talking about a model that truly covers all the possibilities or the reasonable possibilities that may impact the dependent variable. If you leave an independent variable out of a model, it could be that your independent variables in the model aren't the variables really making that impact on the dependent variable. It could be that there are variables left out of the model. So it's important to have a specified model. So control variables are used to specify models because they have an impact on the dependent variable, but they're not important to the research being conducted. They're outside of your hypothesis, but they are important as far as controlling for outside possibilities. Control variables are placed in models to verify that the hypothesized variable is the one making the impact. And the impact isn't really coming from some other control variable. Okay, another thing that your text talks about are moderating variables. These are independent variables. These are causal variables of constructs that show independent effects. For instance, on this particular model, academic achievement is a mediating variable. In other words, it's a dependent variable and an independent variable. So if you look at it, intelligence is hypothesized to have a positive impact on academic achievement. You see the little plus sign by the arrow. That means the higher end of your intelligence is, the higher your academic achievement is hypothesized to be. We pretty much know this is true. So, but when they collect the data, that'll be there. But it could also be that effort also has an impact on academic achievement. Matter of fact, I would argue it has a bigger impact on academic achievement than intelligence. There's a lot of intelligent people that don't have college degrees because they don't have effort. Effort is a big factor in academic achievement. Matter of fact, if you have fairly low intelligence with a lot of effort, you can have high academic achievement. So that's also a moderating variable here. So in this example, because intelligence is hypothesized to be the impact variable, effort is the moderating variable or the independent variable that you have to control for to see if academic achievement is raised. Now, it could be that academic achievement comes with both effort and intelligence, that both of them have an impact. And that's what is hypothesized in this particular model. This particular model also says, because it's a mediating variable, academic achievement is an independent variable for the dependent variable of earning potential. The higher your academic achievement, the more earning potential that you have. So you have that plus sign there on that. So you can see how these models are often constructed in social sciences. And you can see that what you'll have hypothesized here, what you'll need now is you'll need that data to see if your hypothesis is confirmed by the data that you collect. If the hypothesis is that intelligence causes academic achievement, then effort could be a control variable, a variable added to make sure an outside cause, which is effort, is not the cause of the relationship between intelligence and academic achievement. Because it could be that people with intelligence have more effort. That could be the case. So if that's the case, then we have to figure out, is it intelligence or is it effort or is it both? Hypotheses. Hypotheses are empirical formulations of propositions stated as relationships between variables. When we say empirical, remember that's numerical. So when we say empirical, we're doing quantitative analysis, number comparison to see if the relationship exists. Hypotheses are used to formulate these empirical propositions. An example of this would be the previous slide that shows a hypothesis that intelligence causes academic achievement and earning power. That's a hypothesis. The empirical formula would show the construct and how it is measured to test a hypothesis. So the construct would be intelligence. How are we going to measure intelligence? The variable would be the IQ test. For effort, that would be the construct, effort. How we measure that? Perhaps it would be hours studying or some combination of variables. That could be multidimensional. Hours studying, concentration levels, so forth. Those things can measure effort. And so we would measure those with numerical values, and those numerical values will be compared to the other numerical values for the dependent variables. Earning power could be measured as income. Academic achievement can be measured as GPA, or whether you've achieved your college degree. Those are numerical numbers that measure the variables that measure the construct. So the test that IQ causes higher GPA and more income is a hypothesis. And these hypotheses are what drives statistical analysis. So hypotheses can be strong or weak. Non-directional hypotheses are weak. That's the description in the textbook. I agree with the description, but there are disciplines that don't agree. In some disciplines like psychology, it's almost universal that all hypotheses should be measured as weak hypotheses, non-directional. In social sciences, when you come to economics, political science, sociology, in most cases, strong hypotheses are what drives the data. And it's very, very rare where you see a hypothesis that isn't directional. I mean, if you think intelligence creates academic achievement, we don't think intelligence reduces academic achievement. We think intelligence increases academic achievement. More effort does not decrease academic achievement. It increases it if it does anything at all. So those are strong hypotheses where we have a direction. The hypothesis that says, okay, we just hypothesize that intelligence will make a difference in academic achievement. We don't know which way, but we're going to hypothesize it. Theoretically, you don't really have a theory for that. It doesn't make sense. And so that's a weak hypothesis too. Theoretically, you want a strong theory behind you. A strong theory would have, in almost every case, with rare exception, there are exceptions, but with rare exception, a strong hypothesis and a strong theory will have a direction where you will see which direction it'll go. So weak non-directional hypotheses are not really common in sociology or political science research. In most cases, they have a direction and they're strong. Now, theories are important. They're important in research. A theory is a set of systematically interrelated constructs intended to explain and predict a phenomena of behavior or of interest. Okay, so most theories are causal in nature. So a theory will say, I think this causes this. In most cases, that's how theories go. It's rare that theories don't have some directional cause, and in almost every case, they are causal in nature. They also should be derived from observational facts. You shouldn't just come up with a theory arbitrarily in your head. Arbitrary theories would just match two variables together without really good explanation. You should be able to see, okay? If we see that smoking increases the chances that you'll get cancer, we should be able to see that by looking at people who are smoking and seeing that more of them are getting cancer than people who don't smoke. If that's the case, then we have observational facts that we're basing it on. Okay, so, on the other side, it could be, somebody would say, well, driving a car causes cancer. We don't have any evidence that driving a car causes cancer. We don't observe that. And until we observe that and we can see that, there's no reason to really have a theory behind it. if you go up there and see if there's a correlation between those two things and you say nothing and throw it out, that's not really theory. A lot of times people will look at correlational tables and say, okay, what's correlated here? And they see high correlation. They say they have a theory that correlation is causal. They don't really, the theory should come before the correlation in almost every case. Now, sometimes it doesn't because we keep seeing this data. But in most cases, you have a theory and then you look at data and say, okay, does my theory hold water with the facts, with what we're seeing in nature? So theory should be the start of research. And that start of research should be from observing the world and coming to conclusions. Theories explain what's going on, and people are generally receptive if they have a good explanation. If you don't have a good explanation, you can stretch. You can stretch these things, and people say, "Well, I just don't believe them." That's problematic. If it doesn't make street sense, then it's hard for people to accept it. Then it could be that some theories are acceptable, but what you'll need to do is explain it, and you need some facts behind why you think that particular impact, that causal impact, is going on. Viable theories make for good empirical testing. So if you see a theory, we can get measurements and then test it and see if it really holds water. Theories should evolve too. As time goes by, we see a theory and then we say, okay, we test it. Okay, this theory seems to be true, but let's get into the inner workings of it and see what's really going on. And that way, then you can start building on your knowledge and understanding better what's going on in the world. And that's why theories have such high value. I want to thank you. This is a very short chapter, as I said, short video. Hopefully this will help you. I know it covered a lot of information on your chapter questions for your multiple choice test. So I wish you well and wish you luck on that. And I'm hopeful that you will do well. If you have any questions or needs, shoot me an email. I'm happy to talk with you by Zoom as well. Have a great day.